In this example, we're asked to determine the centroid of the enclosed area shown. This is a centroid of a composite area type problem, and to begin, we're going to divide the area shown, which is a complex area, into simpler known shapes. So I'm going to start by trying to identify simpler shapes within this area. And I'm going to pick out do it in red, I'm going to pick out this rectangle here. I'm going to call that A, piece A, or shape A. So I have a rectangle. I have a triangle here. And I'm going to call B. I have a quarter circle over here to the left of the y-axis. That I'm going to call C. And then I have this negative area here, which is a semicircle. And I'm going to have to remember that that is a negative area and subtract that out, because as you can see, the rectangle includes that hole, or that where there is no area, or there's no material, if you want to think of it that way. And the quarter circle also includes that portion that's not there. So if I just solve the problem with the areas, smaller areas, simpler areas, A, B, and C, it wouldn't take into account that there's area missing there right around the origin where that semicircle is. So I need to also include that shape, and I'm going to call that D. Okay, and I need to treat that as negative area. So let's go back and write down the quarter circle. And which is C, and then D is a semicircle. Okay, and that's enough for the colors, I think. Now we're going to need to be able to calculate the area of each of these smaller, simpler areas, as well as determine or look up their centroids. And we know how to find the area of a rectangle and a triangle and their centroids. We've been doing that in the course. But the quarter circle and semicircle, we're going to look those up, and we find that the area of a quarter circle, and you could probably figure this out, it's 1/4 of an entire circle, but it's pi r squared over 4. A semicircle is going to be pi r squared over 2. And then we need to know their centroids, and we'll call those to be consistent, x tilde and y tilde. So the x location of the centroid of a quarter circle is 4r over 3 pi. And again, we looked that up on the internet, in the textbook. It shouldn't be hard to find that. And it turns out that y tilde is also 4r over 3 pi for the quarter circle. Now the semicircle, by symmetry, x tilde is going to be 0, and y tilde is also 4r over 3 pi. Okay, and we need to remember that the semicircle is going to be negative. We need to subtract that out when we do our summations. Okay, now I'm going to make a table to keep track of everything. I really recommend doing this because it gets, if you have more than a couple pieces, it's a lot to keep track of, and I think the table may take you a little bit longer to set up, but in the big scheme of things, it'll probably save you time. So I'm going to call my first column piece. I'm going to have an area column. My units are going to be inches squared for that. I'm going to have an x tilde column. Units are inches. A y tilde column. And then I know I'm going to need to find the moment of that area about my reference axis. In both x and y. It's going to be in inches cubed for an area, moment of an area. And then I'm going to have a y tilde a, which is also going to be in inches cubed. Okay, so for piece A, that's the rectangle. The area of a rectangle is height times width. So the rectangle A is going to be 18. X tilde, now you need to be a little careful with these. And we'll go back to colors here. I need to take into account I need to determine the distance of the location of the centroid of the rectangle from the x and y axis. Now, this one's going to be straightforward because the left side of the rectangle is right on the y-axis and the bottom of the triangle is right on the x-axis. So I know that the x-coordinate of the centroid of a rectangle is half the base. So x tilde is going to be 3 in this case. I don't want to keep on with the colors here. It's going to be 3. And y tilde is going to be half the height, or 1.5. And again, since the base is on the x-axis, it's just the straight 1.5. Now when we get to the triangle, we'll see how you need to take into account that it's the distance of the centroid from the x and y axis, and I'll show that when we get to that. Okay, so I'll go ahead and do these calculations while I'm here. X bar A is going to be 54, and I'm sorry, X tilde A is 54, and Y tilde A is 27. Okay, now before we go on, we're going to use the equations we developed in the lecture. I probably should have done this at the start of the problem, but we're doing all this so we can use these equations to solve for x bar and y bar of the composite area of the entire area. So you can see we have our x tilde A column, our y tilde A column. Once the table's complete, we'll sum those columns individually, and we'll also sum our area column, and we'll have numbers to plug back into these two equations. Okay, B is the triangle. We know the area of a triangle is 1/2 base times height, so that's going to be 4.5. Now x tilde of the triangle, notice the left side of the triangle, the left leg of the triangle, is not on the y-axis. So local to the triangle, we know that I'm going to draw this in black so we'll see it. We know that the centroid of the triangle is going to be, if the triangle base is 3 inches, we know that it's going to be 1 inch from the left side of the triangle, left leg of the triangle. So x tilde needs to be the distance from the y-axis, along the x-axis. So it's going to be the 1 inch plus the 6 inches. Or 7 inches. Y tilde, we can just calculate that directly. It's going to be 1/3 of the height of the triangle, and since the base of the triangle is on the x-axis, it's just going to be that 1 inch. Now we calculate x tilde A, 31.5, y tilde A, 4.5. Okay, now I have my quarter circle, C. The area of the quarter circle, it is 4r over 3 pi. I'm sorry, that's incorrect. It's pi r squared over 4. So if we plug in the radius of that quarter circle, 3 inches, we will get 9 pi over 4, and I'm just going to leave it like that and do the math later. Okay. Now x tilde is 4r over 3 pi for a quarter circle. But notice here that the quarter circle is on the left side of the y-axis. In other words, that distance to that centroid along the x-axis is going to be negative. Okay, so it's going to be minus 4r over 3 pi. And I'm just going to write it like this. And again, I'm going to just do the calculations all at one time. So it's minus 4 times 3 over 3 pi. Y tilde, that's going to be positive 4r over 3 pi, which is 4 times 3 over 3 pi. And then when I find x bar a, x tilde a, that's going to work out to negative 9, and y tilde a is going to be 9. Let me write that better. Okay. Now the final piece was that semicircle, which is a hole, which is negative. There's nothing there, so we have to subtract that back out since we already, between the rectangle A and the quarter circle C, we've included that area that semicircle sits over, so we need to subtract it back out. Okay. So the area of a semicircle is pi r squared over 2. So r is 1 here. So it's going to be pi over 2, but it's negative. Okay. X tilde, with respect to the semicircle, is 0. And the semicircle is centered on the y-axis, so x tilde is 0. Y tilde is 4r over 3 pi, or 4 times 1 over 3 pi. Okay. X tilde a, negative pi over 2 times x tilde. So x tilde is 0, area is negative pi over 2, so that's 0. And then y tilde times negative pi over 2 works out to be negative 2/3. Okay, now we're going to sum the area column, the x tilde a column, and the y tilde a column. And again, I'm not going to do all this out, but when you crunch these numbers, you get that the total area is 28.0. And again, that's in inches squared. When you sum the x tilde a column, you get 76.5, and that's in inches cubed. And when you sum the y tilde a column, you get 39.83, and that's in inches cubed. Okay, so these are the summations here. of the three things that we need to calculate x bar and y bar of the entire composite area. So I plug and crank for x bar. I'm going to put in the 76.5 inches cubed. And I'll put the units in there to show you how the units work out. The area, total area, was the 28.0 inches squared. You do that math and you get 2.73 inches. Y bar equals the summation of the y tilde a column, which is 39.83 inches cubed, divided by the area, which is going to be the same as it was for the x bar equation. And you do that math and you get 1.42 inches.